In Physiology 1, Biology 345, I'm Bob. I will learn your names eventually, even with the masking. I know many of you, but I'm going to work on learning the names of the rest of you. Zoom people, can you hear me? Give me a sign. Okay, good. Okay. So let's get started. As always, as all your professors always do, I urge you to read the syllabus. So I'm not going to, in a normal semester, I take some time to go through it, but these are compacted semesters. We're going to be running at double speed, and so learn the information from the syllabus by reading it. I am happy to answer questions about anything you read on the syllabus. Standard operating procedure is there will be handouts on the back table, or maybe I might move them to that table out there just to reduce congestion. So look for a handout every class. There won't be as many as today on every class, but there will always be a handout. I print out the selected slides from the PowerPoint for you to mark up and take notes on. I don't print out everything. I print out the ones that I think are most important for you to have. The PowerPoints are, well, let's just look at Moodle. So here's the Moodle page, which I recommend you use regularly. So here's the syllabus. Okay, I need to do a sound check. Abby, can you hear me in the back of the room?
Yeah, I can.
Good, okay. So here's the syllabus and the schedule. There were 2 copies of the schedule. You should pick up the one for the version of the textbook that you have or will have, the 13th or the 15th edition, slightly different pages. Brittany, one of the TAs, will be setting up the Zoom as well as recording these classes. And they will be loaded. I'll make a new link here for the classes from 2021. If you want to look ahead to last year's class, you can do that from the slides, the videos from 2020. But every year is a little different, so this is not as useful as the new link that we will put up for the videos from 2021. Okay? So this is a way to look ahead, and 2021 will be a way to look back. If you're Zooming, if you need to Zoom for any reason, here's the link for classes. And then periodically, weekly, usually on Wednesdays, but sometimes on Mondays, we will scatter to safe locations where we will work together, where you will work together with students, with other students, classmates, on Zoom in a breakout. So there are times when you will be working together safely in a Zoom breakout. And this will be the link for those. So not today, but maybe on Wednesday, I recommend that you bring your laptop with you, if you have a laptop, so that you could go to some place here in CST or maybe in Stanley or maybe right across the way there in LBC for the breakout. That will be in the middle of class. You'll work together on problems, either the problem set or some other problems that I'll hand out. Working together, learning from each other, teaching each other what you know, learning from someone else what you don't know. Peer teaching and learning is a useful way to learn and understand. That's what these breakouts are for. So in the middle of class on Wednesday, we're going to break out. You're going to work with random students, and then we're going to come back, which is why I recommend bringing your laptop rather than having to go all the way to your room. Although that's up to you. There'll be time to move, but you might not want to go all the way to your room and then come all the way back. It'll be your option. After breakout, you could break out and then go to this link for the rest of the class on Zoom. That's an option. But I do recommend, I think your learning will be better in this room rather than on Zoom. Zoom is okay. It's better than not anything. It's better. It's okay. But I think if you have the option of Zooming or coming to class, you're better off coming to class. I think people learn better if they're in a room together. So, again, read the syllabus for information about grading and lots of other things. So here is the first section of the course that we're in. A key concepts list, which was also provided to you on hard copy. This is a list of the concepts. It's not text. Well, it is text, but doesn't have content other than just sort of the name of something. But it's a checklist. You can use this to say, yeah, I understand what he's talking about when he says, understand the sodium, potassium, ATPase. Or not, in which case you go and look it up. So key concepts, the PowerPoints that are there now do not have any answers to any of the clicker things that I have, or any of the think, pair, share. Well, we're not doing think, pair, shares because any of the 1 minute write things. So these, before class, they do not have answers, but you can look, the day before, or maybe the day before, and see what's coming up. And then after, I refresh these files with the copies with the answers for review. There's a problem set coming up already. So there's a problem set at this link. You will, if you click on this link, there'll be a Word file. Is there anybody in this room or on Zoom who has trouble with Word? You can't open a Word file. Okay, great. So, Word file, problem sets are electronic, so you can do them electronically and then you'll turn them in electronically on Zoom. No, on Moodle. On Moodle. This is an assignment, and so you can turn it in here at that link. If you have a problem, just talk to another student who's done this before or to me. The breakout that we will do on Wednesday will give you a time to work with your peers on the problem set. Learning from each other. How are you going to approach question 5? What do you think about question 2A? Can you get into, that sort of thing. So the breakout sessions are a way to learn together. Problem set is due Friday night. There is if you run a Windows computer, you can download a simulation program that you'll need to do the problem set. If you don't have a Windows computer, I had to figure this out yesterday. Your text says something about, has a link, but that link is broken, doesn't work anymore. So don't use the link in the problem set, use this link. It's the same, it's a similar thing, and it gives you the same answers. We'll talk more about that on Wednesday. There's going to be, let's see, so problem set due on Friday. And my goal for problem sets are that you work together. It's called formative assessment. I will assess it. It's part of your grade. But you can work together, and there's, if you work on it, you'll get high marks and you'll learn from it, and that's the goal, is learning from the problem set. I'm happy to help you and give you guidance. It's not like a quiz or an exam. It's different because the goal is to learn. But it has value for your grade, so you incentivize to learn from the problem set. So feel free to talk to other students, use the internet, use me, use Brittany, your TAs in lab, to learn from the problem set. Quizzes are different. Quizzes are closed book, no notes, can't cheat sort of thing, can't work together. You'll pick the quiz up here at the CST desk, sit down and take it, and turn it in right there. It's on paper, it's not electronic. Except for those of you who are on Zoom, and I'll work that out with you. The schedule says it's due on Sunday, but I thought about that this morning and I said, I'm going to make the quiz due on Monday at 9 p.m. So an extra 24 hours between the problem set and the quiz. The quiz is mostly anatomy. The problem set is mostly physiology. And the exams are a mix. 2 weeks from today, we've got the exam. That's part of this fast pace that we're in. So use Moodle, because I can update Moodle even after I've gone to press on something that has been copied. So you might want to annotate your problem set. No, annotate your schedule to say that the first quiz is not due Sunday, it's due Monday. Okay? If you're going to refer to the schedule, you want to make sure it's up to date. Any questions so far about how the course is going to run, sort of? It's just the running of the course. Interactive lectures in this room, breakout sessions, problem sets, quizzes, and exams. I mean, it's pretty standard. Meg?
I know last semester we turned in problem sets that CSP desk and under your door. Is it just electronically now?
Yeah. I'm gonna, and if not, I will make sure it's clear that, okay, this one you have to print out and turn in under my door or at CSP desk. The first one is electronic. If you're the sort of person that likes to write things out, I'm okay with that if I can read your writing and you can scan your answers or take a picture of your answers and turn it in electronically that way. But most of you are better at keyboarding your answers. So these are the main points of the syllabus. So I'm gonna skip this. But the syllabus, well, I guess I'm not gonna skip it completely. It's got policies, it's got some tips, some recommendations that I have after many years of teaching this course, what has worked for many students, things to do and things to not do in order to succeed in this course. And then I think they're especially important when we're running at double speed like we are. You know, problem sets, grading, attendance, accommodations, communication. Everything like is in the syllabus, please read it. We're going to have 3 anatomy labs, sections. So we're going to divide up into sections now. So the 3 sections are Thursday evenings, Friday early morning, 8 to 10, and then Friday later morning, 10:15 to 12:15. Those are the 3 sections. Taking 3 hours of lab and compacting it into 2 hours of lab, taking 14 lab sections from a semester and compacting it into 7. So we're going to work hard you have to be fully present during your 2 hours of lab each week. So there's a late penalty for coming late. You'll have 1 hour of working with the cadaver and 1 hour of working on a computer program. If you're on Moodle, if you're distanced and you can't come to lab, obviously you can't do the cadaver, but you can do the computer program and I will make that available to you. So even if you're in the room now, if for some reason you can't come to lab during that week, let's just say you're in quarantine, we'll work it out. You just have to let me know and we'll work it out. I will not penalize you because you're in quarantine. So most of you who are going to work in the cadaver lab are going to join this fraternity, this community of people who have worked on a cadaver. right? It's an amazing experience. I don't look like this guy, you don't look like this guy. Our cadaver actually looks pretty much like this guy. And so this is experiential education as far as anatomy is concerned. It's a way to learn the anatomy of the muscles that you're going to be learning from books and paper. But it's also the experience of what it's like to work on a human body. You will gain the same experience that these gentlemen did back in the 1500s, well, 1600s, sorry. So it's amazing. I mean, and Earlham is is one of the few small colleges that offers this experience. So appreciate it and get the most you can out of it. So we need to partition into the lab sections, and we're going to do that now. So the first step is your name on this list? If your name is not on this list, you need to tell me. Okay, so what we're going to do now is let's try to do this. I've taken that same list and I'm going to put it in my favorite program. And we are going to randomize. We're going to randomize this list. We're going to go down the list from top to bottom. You're going to tell me which lab section you prefer. Brittany and I will keep track of the filling of the sections. The sections fill at 8 students. So if a section gets to 8, that section is no longer available and you have to choose what's left. So obviously if you're, if you're in the first 8 on this list, you're going to get what you want. So and then if you get put into a section that is impossible for you, we'll negotiate trades. It has always worked. I've done this for years, and everybody's been able to take the course. So it has always worked, and that's a testament to flexibility of the Earlham students, helping each other out. Okay, Samantha, you win. You get to choose.
Can I have the Friday at 10:15?
Okay, so we just, let's see. All you have to do is tell me 7, 8, or 10. 7 p.m. Thursday, 8 a.m. Friday, 10, we'll just call it 10, but it's 10:15 on Friday.
10.
Okay, so you're choosing 10.
Yes, please.
Okay, who's next? Zoe.
10.
Yeah, that's my expectation too. Christian.
10.
Hannah. Hannah, I got 2 Hannahs. Hannah Haybor?
8.
8. Lindsay.
8.
Henry.
7.
7. Michael?
Can I get that? Can I just one Friday?
10. Nathan?
10.
Meg?
I'll do 8.
Connor?
8 o'clock.
8? Eight, right? I got that right? Okay. Jenna?
10.
Berto?
Is this the room for 10?
There's still room in 10.
I'll take 10.
Olivia?
8, please.
I didn't hear it. 8? Logan?
8 is a vote.
Eight for Logan, okay? Andrew?
8.
Katie? 7. Elena?
7.
7? Hannah Barr?
8. 8, okay. 8 is now full.
8, Friday at 8 is full.
Yep.
Okay? Friday at 8 is full. That was unpredictable.
I agree.
Abby?
7.
7. Ramsey? Okay, so, I don't know. Anybody know Ramsey? Ramsey Jaden?
I think so. I'm pretty sure I know him. I'm not sure where he is though, so.
And he didn't communicate to you about this?
No, he didn't.
Okay.
I can try to contact him though.
Vincent? It is.
Last one.
You just filled it. Okay, so what that means is, Sarah, you're in 7. I put you in 7. Can you do, so I'm gonna have to put Jaden in 7. If you're in contact with Jaden, tell him he's in the 7 o'clock on Thursday nights lab. Excuse me. Sarah, are you okay with 7 on Thursday night?
If athletics is an excuse, then no, I'll have practice in the evening sometimes.
Right, so athletics is gonna be an issue at 7 p.m. So let's do the trade then. Is there someone who opted for Friday who could trade with Sarah so that she can get the most out of lab, because her lab experience will be negatively impacted by athletics? Is there anybody, online people too, Roberto, Michael, or Vincent? Is there anybody who prefers Friday morning but could do Thursday evening? Okay, well, if Jaden, Jaden's also in the same boat. I'm gonna put you in Thursday evening at 7. Talk to your coach about how frequently that's gonna be a problem. And then let's work it out. Okay, so we're in lab, so make sure you've noted which lab section you're in. And don't be late on Thursday night or on Friday morning. I'll show you, the other TAs are, who are the other TAs? The other TAs are
Abby and Elena.
Elena, and Elena, what's her last name?
Hornack.
Elena Hornack and Abby Zanata are the other TAs. Brittany is TAing on, what's your schedule?
I'm 8 to 10.
8 to 10, And Abby is 7 to 7, Abby Zanata's TA next Thursday evening, 7 to 9, and Elena Hornak is TAing the Friday 10:15 slot. Okay? So these are, excellent TAs. We will help you, learn how to use the program, pretty intuitive, and teach you what to do in the cadaver lab.
Also, just while we're on the subject, I do have drop-in office hours, TA hours, on Tuesday nights through Academic Enrichment. You have to sign up through their online thing, but you can also contact me for one-on-one tutoring.
Online people, could you hear that? Okay, so Brittany was saying that she's available for scheduled peer tutoring on Tuesday evening. You use the Academic Enrichment Center site to do that. Is that right? Did I get that right?
And one-on-one. And one-on-one tutoring?
And so one-on-one and
The drop-in.
small group drop-in
Yeah.
tutoring. All right. So we're going to transition now into the course, the material, content. Okay, everybody ready? Buckle your seatbelts and let's go. So here are the main concepts from Self-Phys that you want to review and, refresh your knowledge on, because we'll be using it. I'll be going through some of this in review, but I'm moving at a rapid clip. So these are topics that you might need to go back to your Self-Phys level notes to catch up on. Recall from cell physiology that we have 4 types of solute transport. We're going to need to know this to understand the physiology of nerve and muscle cells. That is the first part of this course. So some molecules diffuse through a lipid bilayer. So this gray block thing is the lipid bilayer. You know it's not a gray slab, it's phospholipids and cholesterol, remember that, but in a cartoon it's just a gray slab. Some molecules diffuse right through lipid bilayers, but for this course, that's not going to be an important factor, because the most important physiological ions that do this, physiological molecules that do this, are carbon dioxide and oxygen, and respiration, gas exchange, is in the other course, not this one. There are ion channels that are very important for this course. They mediate passive flow of ions down their electrochemical gradient. From a high electrochemical concentration to a low electrochemical concentration. There are passive transporters that are like channels, except that passive transporters transport their solutes one at a time, one solute per conformational change, whereas channels allow solutes to flow hundreds or thousands per conformational change. So channels undergo conformational change from open to closed. When the channels are open, solutes flow hundreds of them per opening. Whereas transporters, passive transporters, allow solutes to flow down their concentration gradient, but one solute molecule per conformational change, not hundreds. They're both passive. Solutes flowing down their electrochemical gradient. What's the difference between a chemical gradient and an electrochemical gradient? Well, I think you have an intuitive knowledge of what a chemical gradient is. From high concentration to low concentration is a chemical gradient. But ions, like sodium or potassium or chloride or calcium, respond not only to their flow not only down their concentration gradient, but because they are ions, they respond to voltage. And so for ions, we talk about electrochemical gradient. For neutral solutes, there is no electrical part, it's just the concentration gradient. There are active transporters that create the gradients. And we're going to talk about two classes of active transporters. Primary active transporters that take the energy from ATP, and you remember all that good stuff from self-phys about how you make ATP, glycolysis, Krebs cycle, electron transport chain. We're not going to do it anymore. I just covered self-phys in 5 seconds. ATP is converted into a solute gradient. There are secondary active transporters that take the solute gradient of one solute and use that energy to transport another solute up its concentration gradient or electrochemical gradient. So it's transforming one solute gradient into a gradient for another solute. It's energy transformation, either ATP or a gradient to make a gradient. So let's do a clicker. You each have, you know the drill here. Those of you who haven't had me in a class before, but took self-phys, did you do this in self-phys? Okay. So let's take a 3-minute break, not a break, you're going to be working hard. I'm going to try to set up. And take a 3-minute break and do this problem. And you know one of the advantages of doing these clickers this way is that you can choose more than one correct answer. I want you to answer the question and show me your answer. Most in part because I think the act of making the answer in your mind helps you understand what you understand and what you don't understand. And it helps me see where the commonalities of understanding and non-understanding are so that I can be efficient about what I have to teach. Because if you all get it right, I don't have to teach it. I can move right on. So we're talking about the differences between simple diffusion and channel passive transport. Okay, go ahead and show me your answers. Okay, I see a wide range of answers, some of them perfectly correct, and some of them partially correct, and some of them partially wrong. Let's go through this. Let's spend a few minutes going through this. So B, C, and D are all true statements here. So in the past, I have taught this. I'm sort of backing off a little bit because of time. In the past, I've gone through this. but in the interest of time, well, let me just go through it. So both of them are passive transport. So both of them require a gradient for flow. And so A is false. Channel mediated transport also requires a gradient. Simple diffusion, the solute contacts liquid. Channel diffusion, the solute does not. So that's a true statement. Simple diffusion happens without protein conformational changes. There's no protein. Channel-mediated diffusion depends on protein conformational changes from a closed to an open configuration. So C is true. Channels are selective. Most of the channels that we talk about are sodium channels, or potassium channels, or calcium channels, or chloride channels. They are selective, more or less, but they are all selective, at least partially, for one or a small number of solvents. There are a few exceptions, but as a rule, you should think of sodium channels being selective for sodium, and potassium channels being selective for potassium. Okay, let's do another one. What are the similarities this time, between channels and passive transporters that are not channels, the uniporters? So we're talking about the similarities between these and these. Okay, take a minute, think, remember, and I'll ask you to show me your answers in a moment. Okay, show me your answers, please. Okay, most of you are getting this mostly right, some of you are getting it all right. They're all true statements. So the one that tripped up some of you is this one. And this is an important concept, that in order for channels and transporters to be selective, which they are, this cartoon is misleading. It suggests that that the ion just flows through the channel. There are contacts here, binding sites, that make sure that the sodium channel is only allowing sodium and not allowing potassium. So B is a true statement. There are specific contacts between the solute and the protein, the transporter. The specificity of those contacts is what makes for selectivity of the transport, of the channel or the transporter. We're going to be talking more about binding in a few seconds. Like it or not. Okay, let's do another one. I think this might be the last one. Regarding primary and secondary, so this is asking you to remember from self-is, primary active transporters and secondary active transporters. I didn't teach it. I want to see what you know. I understand that a long time has elapsed. In some cases, for some of you, years has elapsed between self-is and today. But I just want to see what you remember. Okay, show me your answers, please. Okay, so this was a challenge. Somebody who got it right, I want to do a little peer instruction here. Somebody who got A right, that A is not true. Tell us why that's not true. Many of you got this right, this part right. I want to hear it from you, please. Abby.
So primary active transport uses hydrolyzed ATP to get the energy, but secondary uses a favorable concentration group, meaning it's either go together or go.
Right. So, for those of you who didn't hear Abby, primary active transporters hydrolyze ATP, but secondary active transporters do not. They're active because they use another gradient to pump a different solute up its concentration or electrochemical gradient. Only primary active transporters are ATP aces. Okay, somebody who got B right, tell us. Now, did anyone not get, B is pretty obvious. That's the definition of primary active transport, is that they create gradients. C is asking you to remember your thermodynamics from self-is or maybe biochem. Somebody explain what's wrong with C. Some of you got it right. I don't remember who got it right, but I want to hear it in your words rather than in mine. No takers? Abby, please. Oh, no. Zoe.
No, you got it.
Yeah.
Okay, isn't the whole point of active transporters is the fact that there's some energy input? That's the part that counts.
Yeah. I think the idea is creating concentration gradients is energetically unfavorable. Right? You're moving a solute from a low concentration to a high concentration. That is, by itself, that is energetically unfavorable. Things flow downhill. Things don't fly downhill, down their electrochemical gradients. Right? I mean, if you think of a gradient, if you put a ball at the top of a hill, it will spontaneously flow downhill, down its gravitational gradient. If you place a ball at the bottom of the hill, it won't spontaneously go up the hill. It doesn't happen. It takes energy, somebody picking up the ball and walking it up the hill to take it to the top of the hill. Same idea here. The energy that goes into making gradients comes either from ATP, hydrolysis, or from another gradient, depending on primary versus secondary active transport. So if this is just completely mystifying to you, you need to review your cell phys level concepts of energy, free energy, and entropy, because we'll be using some of that language. D, somebody who got D right. So, somebody who got D right, explain it to us. Sarah?
Well, I feel like it's kind of defined in the parentheses on its own, in that the definition of an enzyme is to lower the activation energy and to make reactions go faster, which is what these proteins do.
Yeah, that's true. So sometimes the answer is in the question. That this is a learning thing. You just know, sometimes I have to give you the answer, and if you're reading the question carefully, the answer becomes obvious. But this is the definition of an enzyme. Right there, lowering energy barriers and accelerating reactions is the definition of an enzyme. So primary active transporters are easily identified as enzymes because they hydrolyze ATP, right? Hydrolysis is a type of enzyme. Secondary active transporters are also enzymes, even though they don't break any bonds, because they do this. Okay, so like I said, this is redundant. I'm going to skip this slide. Some solutes diffuse, but they're not very important for this course. Ions that are very important for this course, sodium, potassium, calcium, and chloride in particular, do not undergo passive diffusion to any extent. They are either transported actively or passively. We're not going to talk too much about the other molecules. So now I want to talk a little bit. I'm just trying to figure out where the breaks come. Let's take a 5-minute break right here. Okay? Just get up, stretch, run around the building a minute just to get your juices flowing. We'll do that periodically. We're not going to do a breakout today, but I do want to give you breaks to, get your blood flowing. So we'll take a 5-minute break.